Good morning. Good morning, JFocus. I'm glad that so much of you are here after the party yesterday. So I'm really appreciate that. I want to talk about lost in transaction, or better, how to avoid to be lost in transaction today. My name is Bernd Rücker. You find my contact details over there. We might run short in time at the very end, so if you have any questions, feel free to send me an email, feel free to Twitter me. We have a booth, just the first one in the second floor, so just approach me. I'll be there the whole day, so if you have any questions afterwards, that's a good opportunity to do that. So we see a world nowadays where we see a lot of web services like REST calls. You might probably move some of the components you have in the cloud or using some SaaS or PaaS or whatever it is. You might even build a microservice environment. You might build self-contained systems or whatever it is. And everything or all of that basically includes to have some remote communication. Who does not have remote communication in his system at all? So I don't see any hands. So that's the setting we currently have, and that means we're dealing with distributed systems. And I like this picture to have about distributed systems. And that means you have this, like the small hut over there. That's your single application, your single service. That's on one JVM. There you have transaction management. You're having your heating. It's kind of comfortable and cozy to be in there. But whenever you open the door, you're looking out to that ocean, and that's quite rough. And that's the network, that's a distributed system. And there, basically, a lot of things will break, the network will be not available, it will shift bits, it will lose messages, it will duplicate messages. So there will be a lot of things that happens. And that poses a lot of new challenges onto us as developers. And that's what I want to talk about today a bit. And I basically selected 3 challenges. There are much more, but I selected these 3. What I want to do today. So I want to go over basically communication, complex communication in distributed systems. It's more or less about synchronous communication in the beginning. Then I wanted to look at asynchronous communication. And then basically what gave the talk the name is about distributed transactions, which is quite an interesting topic in that area. So that's my plan for today. I hope that's pretty fine for everybody. So let's assume you have this kind of situation. So it might be microservices, might be self-contained systems, it might be just a couple of applications which have to communicate with each other. And one mind shift we currently see is that if we have these kind of complex systems, is that we start to accept that there will be failure somewhere in the system. That was not always true. I mean, in the past, there was very often, I were in meetings or discussions where they said, oh, we made it high available. It will be there. You don't have to care about that. It will be just there. And we start to accept that it's not possible at all, and it's much too expensive to make things really, really that available. So we accept this kind of failure. But what we have to avoid is that basically leads to cascading failures, bringing down my whole system, bringing down basically everything. So we have to keep failure local. We have to degrade the functionality, for example, in order to be resilient to still work. Let's make a simple example. So I have that example where you can imagine to provide a payment service, probably within the company. So you want to retrieve payments for whatever. And that might involve to call an upstream credit card service like Stripe. Okay? And let's do that with a bit of code. Let's do that live. I basically have a payment service here written in Java, obviously, using Spring Boot. So it's quite a very small service. And that calls an upstream REST service, which I also have on that machine. That's hopefully an easy setup to go. So let's quickly look at that. So what I basically have is there, that's my upstream service. So that's just a REST service doing the credit card thing. And then I have also having a service which does the payment. And how does that look like? It's a very easy one, actually. So I used Spring Boot here, so I can just do stuff like having a REST controller. That basically has a REST API, which I can call. It retrieves payment for me. Basically, I make up all data because it's not relevant for the example. And then I charge the credit card. That's what I typically do here. And how do I charge the credit card in a in a Spring Boot environment? I just use the REST template, do a post, basically send over something to Stripe in this case, waiting for a response, and that's it. Hopefully understandable, easy code, right? Who has written something like this in the past? Okay, that's basically a whole audience, so you don't have to talk about that. So let's have a quick look at that. So what I can do is I have my Postman, I have the upstream Stripe service, and I can do a request. And what I see is that it basically goes through, and that's now the second service I called. So far it's pretty boring, I confess. But now I can do something and can make the service slow. What happens if I have a slow downstream service and I now call my retrieve payment service? Timeout, probably, or that's a test question. It's an easy one, actually. It's just to check if you're awake. It's slow. I mean, I'm having a slow upstream service. I'm calling it synchronously. I'm blocking, so this one will be slow. So it says it takes 45 seconds. It's actually random. That means I'm blocking for 45 seconds. Don't want to wait for 45 seconds. I'll go back to the slides and tell you why I'm talking about that. So why is that bad? It's actually very natural, but if you think about that, if you're having that payment service, where's my mouse? If you're having that payment service, that has a thread pool attached. Might be 50 or 100 or 200 threads, whatever, but that means if the upstream service is slow, all of these threads are blocked, they're waiting for the response, and that means your payment service cannot respond anymore. And that means you're having a cascading failure, starting to set up your whole system on fire. That's pretty bad. This one is still blocking. So what you can do about that? So you probably heard, and that's one of the easy patterns to get started with. Who knows about the circuit breaker? Okay, that's awesome. That's a lot of people. It's actually, so Stockholm is pretty good at that. So you should know about the circuit breaker. Everybody not raising his hand now, that's a homework to check. Circuit breaker is very easy, so I have a second version of that. I charged my credit card. The only change I did here is I basically encapsulated that call, that REST call, into a Hystrix command. So Hystrix is one example. It's from Netflix. You could use other frameworks as well. But there, you could service mesh, sidecars. There are a lot of things going around doing this kind of thing. But what you can see is that it's pretty easy to apply, and it changes the whole game. So now we have a response in 45 seconds. And if I do the version 2, and we still see that the upstream service is slow, I do something, but I now get a timeout from the circuit breaker. And I don't block it. So that's already a huge improvement. So that was kind of setting the scene here. So I don't have to talk about circuit breaker a lot. You know the pattern, it's like in your house. If there's something weird with the electricity, it just switches off before the house burns down. So that's the same thing here. So this is very much known as fail fast. So we want to fail fast instead of blocking everything and cascading failure and these kind of things. And this is something most of the people know, actually, which is pretty good. Can we do the question later on? Is that okay? Or is it very important? Yeah. We get to that. We get to that. So currently we're failing fast, but that's not enough, and that's what a lot of people don't have in mind when they're talking about these kind of things. And I make another example because that happened to me a lot actually. So when you're flying, when you're booking a ticket, then you're getting a check-in invitation via email typically, like 48 hours before the flight. And then you click on a link, then you select a seat, and the last thing you do is you press a button, send me the boarding pass. You probably know that, yeah, right? So send me the boarding pass. And what happened to me when I did a flight to London last year, it's a German webpage, sorry for that, but what it basically said is there was an error sending your boarding pass. The first thing to notice was they seem to have some kind of circuit breaker. So I imagine it's something like this. They had that UI, they had a check-in service, and they probably had an own service for the 3D barcode generation, because what I don't know about this airline, but we have other customers, and it seems that output management, PDF generation, 3D barcode generation, it's in 2018, it's kind of a big problem to be. And that means I assume that the 3D barcode generation didn't work. And just my assumption, they had probably a circuit breaker in there. So the web page was available. I could still do everything, but I couldn't get my boarding pass. But so that you could argue that's kind of a nice situation, but it's not, because what they did is basically they had a failure down there, and they basically moved that failure back to me, in this case, even as a user. So I got the error message, but I don't have my boarding pass. I mean, I need the boarding pass to get on the plane. So that's kind of an important step there. So what they basically do is they move the failure handling to me as a client. And in this case, I did a retrying. I mean, I asked that question very often, what would you do? And I got an answer like printing the page. That was business user, which I don't think brings me any further at the airport, or calling the airline. That's kind of the management answer, just doing something. But the programmer answer is I retried. I retried like after 1 minute. I retried after like 5 minutes. It didn't work, by the way, and I retried it on the next day, and that did work. But I had to make me a calendar appointment. I have to think about that. I have to retry it myself. And that's actually a pretty bad experience. And you can transport that also to service communication. It doesn't have to be the user. It can be an internal service, but it means that the failure handling just leaves a small scope and start brittle through the whole architecture. That can lead to a lot of architectural complexity there. The funny thing was that on my flight back from London, I had a different airline with the same problem, and they gave me the work instruction, actually. That's awesome. Because they said, okay, we're having technical difficulties, but please log on again, retry it immediately. If that doesn't work, please try again in 5 minutes, increase the interval. And we do actively monitor that, that's the best. And we will be working to resolve the issue. There's no need to call, it's your problem, leave us alone, do it yourself. So it's really deep in there. It would be much better if they do something like, okay, we are having technical difficulties, but it's no problem, we care about that. We send you the boarding pass in time, relax. That would be much better. And even for service-to-service communication internally, how do you do that? I mean, it's pretty easy. You have to move that retry to the check-in service in that case. And then you limit the scope where you have to apply it. And that's a much better architecture, especially in that use case. I mean, it always depends on the use case. The thing is that it has to be stateful in this case, because, I mean, if they promise me to send the boarding pass, they should do it, actually, even if they have the system outage, a restart, or whatever it is. And in my example, I had to wait for the next day in order to get it going. So that has to be stateful. And from my experience, that's why a lot of developers are not going down that route, because they basically fear the complexity of handling state. How can you handle state? So one of the most common ways of handling state is what I call a persistent thing. So it could be an entity, a database table, basically, or a persistent actor if you're running actors. And then people think about that and say, no, I don't want to do that, actually, because then I have to do the retrying. I need a scheduler querying that. I might have like thousands of people waiting for that retry, so I have to operate it at scale. I probably have to look into that in order to see which ones are waiting, in order to retry them manually, in order to cancel that. I might have to change the check-in procedure. Then I have these waiting retries. What about versioning and these kind of things? So there are a lot of subsequent requirements you have to do when you start doing this kind of things. And that's actually true. I saw a lot of these things happen in reality. But there's an easy alternative, which is basically using, it's state. You can use a state machine for that, or most of the common state machines nowadays are called workflow engines. And there are also concerns about that. And they're typically, these are very complex tools. They're very proprietary. A lot of people just know the ones from the big vendors, which are typically positioned as what they call low code, so you can do it without the programmers, which surprisingly doesn't work. And all these kind of things. And these kind of things are not true, and that's an important thing to keep in mind there. And I want to make an example, and if you look at the market currently is, there's a lot of things going on within that state machine market. One of the things you probably already saw yesterday, it's AWS step function, so Amazon does something, which is Amazon only. It's only in the AWS cloud, so it's probably not that interesting for everybody here, but it shows that this is quite a relevant problem. Also, you can look at Netflix, the prototype for microservices. They also do something there. It's called Conductor, or Uber released something last year. So there's quite something going on. And there's a class of engines, open source frameworks available like Camunda Activity or JBPM, which are all written in Java, which are pretty lightweight and which are interesting to have a look at. So I committed to basically all of them in the past. Today I want to show Camunda actually as an example. It's by coincidence because the company I co-founded, so that's what I use today. And I quickly, where's my Eclipse? There's my Eclipse. So how does that look like? And I want to use the next version of my REST controller. And this time what I do is I auto-wire workflow engine. So that's the Camunda engine. How does that work? I mean, that's Spring Boot. We have a Spring Boot starter. So I basically just need the Spring Boot starter as a dependency in the POM. So that's one or 4 lines in the POM. And then I can do auto-wired process engine, and it will be there. It will use the data source, a relational database underneath, provided by Spring. That's the Spring Boot auto magic. And then what I can do is I can define flows which are stateful, and that's pretty cool actually, because what I do here, we're using BPMN, that's an ISO standard in the background. Most of the engines are actually using that. Create a process. Then I say, okay, it starts here. The first thing is calling a service. The service is basically Java code. So it's in this case, it's a Spring Bean. I define the Spring Bean here. So that's just my Stripe adapter. And within there, I just use the code I had already. So that's the code from before, also including Hystrix. So that hasn't changed at all. So I can just reuse that. And then I say I'm done. But because I can make it stateful, I can say, okay, now you can do a retry. And in this case, I just retry 3 times with a delay of 1 minute. So it might be that you even have increasing intervals that you tried for until the next day or whatever. As soon as I have that flow, I can deploy it to the engine. Now it knows about it, it versions it, and so on and so on. And now when I charge the credit card, where is that? I basically just start a new workflow instance. And that's it. That's the only code changes I did actually in order to include it there. And that's what I meant. It doesn't have to be something very complex, proprietary, or not fitting in the architecture. Now, what I can do, we are still having a slow service. And if I call it with a version 3, what you can see is this one returns immediately. I changed actually the HTTP status code, so it says 202 accepted. So it doesn't say, okay, I did the payment, but I said, I got the request, I will take care of it. And what you see in the background, it's still slow. So what happens there, we can actually have a look at that. So within these type of tools, normally you get like some kind of UI. In the case of Camunda, that's Cockpit. There I can see what's going on. And there I see my payment version 3. And there I see, okay, there's one thing waiting that Stripe is being called because Hystrix switched off because it's too slow at the moment. What I can do is actually I can bring that back to normal. So now my service is back to normal. It's behaving normally. And if we wait for another minute, that retry should be hit, and it will actually execute it. If I'm too impatient to do that, I could even, as an operator, do something like this, start again, and then, oh, the retry hit while I was doing that. That's actually pretty bad. Pretty bad timing, but you see this one was now finished. So it does the retry in the background. And what you could also see, it's very easy to do. So that's something that should be in the toolbox, stateful retrying. Now you could argue something, and I did that discussion like hundreds of times, I think, last year. Okay, now you have that nice little workflow engine in there. That's cool. But now you get that 202. You made it asynchronous. And I discussed that so often that, like, for example, with a train company, if you book a ticket there, it's like you go in there, you select the train, you select the seat, then you do the payment, and then you hit the last button, and then it does everything. And they were so convinced that when everything happened, then you need a synchronous response showing the PDF ticket. So this is the discussions I currently have a lot. And the interesting part is, it doesn't mean just because you use that workflow engine that it has to be asynchronous. So I could use the following, for example, that's version 4. What you can see is that I got a 200 OK. What does that mean? The payment is done. Why is that so? Currently, my service is behaving normal. So it's fast. So I can map that to a synchronous request. If I make it slow again, then this in the background switches to a 202. And that's kind of, it's degrading the functionality, but it's working, and it will do the stuff in the background reliable. And that's actually pretty important from the code. It's very easy. I mean, all the code, by the way, is on GitHub, so you can check it later on. You can also run it yourself. Very easy, just Spring Boot, Maven, exec, Java, that's it. And what I do there, it's basically in the charge credit card. No, it's before here. I use easy semaphore in this case in order to wait for a timeout if that process basically finished within there. So there are a couple of tricks, even other tricks you can do. So that's pretty easy to get it to a synchronous communication. Okay, so that's something about stateful retrying there. The important thing to notice is what I did actually, I run the workflow engine as part, or the state machine as part of the check-in service. So there's no need to having some kind of, what a lot of people think, if they hear workflow engine, they think of some central component you run there, some big iron you have to run there. No, it's a library, it's part of the service. So you can really think of that kind of flow as being part of that service. That's an important thought, actually. I come back to that in the very end. And then you have like multiple options to run these kind of engines. So I blogged about it end of last year, so that's on my blog. You can find more information there. And what I just shown you was basically I run the engine as part of my Spring Boot services. So I have multiple services. I run multiple engines, no problem. You could do the same trick using a container like Tomcat, Wildfire, WebSphere, or whatever. In this case, you can run the engine is part of the container, the infrastructure, and then you deploy WAR files containing these kind of flows. So that's also possible. And if you're not running Java, then you run the engine as kind of a sidecar just beside it, probably running on Tomcat or whatever, and that's just communicating via REST. So that's also possible. We have a lot of customers doing pretty much this. So there's basically no excuse not to use this kind of functionality as soon as you move into the requirements of having that. And what you also saw is that you can still have it synchronous. So if I have this facade I just did, there you can have even an asynchronous workflow behind, and then you're basically waiting for that, and either you're getting back an HTTP 200 or an 202. That's very easy to do. Okay. Yeah, so far so good. So I told about this story about these. I want to have my trying ticket as a PDF immediately. And that's actually something I would discuss with the customer, because I think it's not true. I think it's not true. For current use cases I see, for example, the train ticket, I don't want to have a PDF at all. I want to have it in the app. And the same story like with the boarding pass, they have my data. They know how to reach me. There's no need to have it synchronously. If there is an error, so you can think about what's the better user experience. Is it I get the error synchronously, or they call me back as soon as it's working? So who is doing the retry? Who is doing the failure handling? And that's an important thought. And what I like actually is this quote from Todd Montgomery and Martin Thompson. They said that at the go-to conference. So synchronous communication is the crystal meth of distributed programming. It's a bit like we're used to that. It's easy to think in synchronous communication, and that's why we're doing it. And we know somehow it's probably not the best way of doing that, but just the last time, it's so easy. We just do it again. And another time, just another time. So it's probably good to also think about asynchronous communication. Let's assume we're doing things asynchronously here. What does change here? So if we have the check-in component, it probably sends a message, AMQP or whatever it is, to the 3D barcode generator. Then you typically still have to care about, you probably don't get a response back. For whatever reason, it was swallowed by the network, the 3D barcode generator went nuts, whatever it is. So you should design for failure, again, mind shift, and you should basically care about that. And again, you should keep it local. That's what I think. So the same pattern applied here. What they could do is they could move it to me, because they said, I promise we sent you something, and I monitor if I get it, and if not, I retry again myself. But they should do it itself within the check-in component. That's the same thing. You again need state in order to do that. So for example, you could do something like this. Again, a workflow in BPMN, where you say, okay, we sent the command to do it, and then we wait for a response. If we don't get that response, we do something. There are even more powerful possibilities you can do there. So, for example, here I say something like, whatever I do up there, if that takes too long, if the guy gets nervous because he wants to get to the airport, we give him a call. Not sure if that's a good fallback in that case, business-wise. But it's a fallback, and that fallback is applied reliably. And that's a very important thing, and it's very easy to do. Now we are getting towards that question, what if the credit card service was called even if it fails. So I'm actually, what I do is I propose to do retrying a lot. That's what you saw. So that means you probably call services more than once. And that's something you have to take care of. And that's a very important thing, actually, because in distributed systems, what you cannot distinguish is between basically these three situations. So whenever you have a network error, when you call the service, you have no idea if you reach the service, if the service has a problem, or if the service even did the thing and the response got lost. So there's no way of really knowing that. So you cannot just know. So you have to take care of that. And that normally means, I think, retrying is one of the generic answers to that. The easiest thing is to retry it. If you're not sure, to retry it. You could also ask the other one, did you do that, by the way? But that's very often it's more complicated because you have to really look at what you're doing there. So that's very specific to the use case. Retrying is very generic. And that's, by the way, true for synchronous, like REST communication, or also for asynchronous messaging. So that's basically the same situation. And if you're doing things like waiting for a timeout, doing the retry, then a very important requirement for the service provider is to be idempotent. And there's a lot of things you should know the other way around. It's very important to think about idempotency. And I don't go into all the strategies of idempotency there. I'm also writing a blog post currently about that, and you find a couple of informations, at least in the web. But it's just important to have it in mind that service providers have to take care of it. It could be that you have a business ID, which is unique. It could be that you generate like a correlation ID just for one call, which will be the same if you retry it. You could build hashes of messages you send over the wire. And whatever, store them in Redis with a lease time. So there are a couple of strategies what you can do, but it's very important to keep that in mind to make the service provider idempotent. And that's actually something that should happen much more often anyway. Do you know this? Do you know when you're paying with credit card and they present you a screen saying, we're processing your payment. Please do not refresh the site. Don't go away. Something weird will happen. And I do that very often in the train. And it always gives me like my heartbeat moves because I think, oh no, there will be a network loss. Oh, there's a tunnel. Oh no, process my payment. And that's a pretty bad situation. And it should be much more something like this. We're processing your payment. Don't worry, it's in the background. There you have a unique transaction ID. It's in your browser. If you hit retry, we just check the status. Do whatever you want. We keep you covered. That's a much better way of thinking it. And again, the same thing for service-to-service communication. It's not only about the end user. Talking about asynchronous communication. Question to the audience: who operates a message bus and has no problems with that? Do I see any hand? 1, 2. Was that? Yeah? No. Yeah, this one. Okay, so we have 1. Okay, that's like not much for giving the amount of people. And it's actually pretty common. I normally have 1 or 2. And that's actually very interesting. And if I talk to we have 2018 on an architecture diagram, messaging looks awesome. And if you talk to the people, it's basically, I think it's a lot about tooling because they say, okay, we have these dead messages, but we are not really able to look into them. We are not seeing the payload correctly. We have no idea why the message is there, from where it came from, why there is this mixed up data in there. How do I retry it? I want to redeliver it. That's pretty hard. And then the people start building their own homegrown solutions. And I very often hear the term message hospital. Even Sam Newman in his book picked that up, the microservices book. So that's quite of a common problem. And that's insane in 2018, but it's a reality. I started to just accept it. I mean, on the whiteboard, looks fine. In reality, you start to get problems. An interesting observation, I mean, that's a biased view actually from me, or an opinionated view at least. But what I see customers doing currently is, if we have, that's the normal situation, again, from the architecture point of view. If we have something like that workflow engine I showed you earlier, it synchronously calls a REST service. It does a push, basically. It actively does something. The same thing you can very easily do with messaging. You just push the message and wait for the response. But there's a different way of doing that. You can change the direction of communication to a pull model, and then it looks like this. We have that workflow engine, and some other service knows it can do something within there, and he pulls for work, he fetches the work. And if you do that on a broader scale, we had customers, okay, they didn't have yet on a broad scale messaging in place, so they decided against that and using a workflow engine for work distribution, because that's what it can do. Then you can have like services fetching for work. That's more or less like looking in a queue. And that then you get that context, because like these workflows, they have context. There you have a lot of there you can see where a message came from, why the data is there, and what was the history of all that. So that's kind of an interesting thing to look at. The most interesting part, actually, what I think about a lot is distributed transactions. Remember, we're in this distributed system. And what at least happened, I would say, in the last 2 years, is that more and more people start to believe that like distributed transactions, like XA transactions, two-phase commit, doesn't really work. Who's using two-phase commit, XA? Who's happy with that? Okay, there were like 3 people using it, 1 is happy with that. So the best story I have for that is actually, there's an awesome thread at Stack Overflow, where somebody asked, okay, I have this JBoss application server, I started up, and there are warnings from the transaction manager when I started up all the time. How do I get rid of them? Then there's an answer. You just have to go to that directory and delete all the files. Okay, the guy does it, and he responds basically, awesome, that worked, the warning is gone. Well, thank you very much. And what he just did is he deleted all pending transactions, because the XA transaction manager couldn't roll it back. That might happen because we're in that world. And then it cannot do anything, and it has that warning, and it means the operator has to do it manually. Nobody knows that. Nobody understands that. So this is one of the problems of distributed transactions. And the other one, it simply doesn't scale. There's an awesome paper on that. So if you don't believe me, that would be a good read. From Pat Helland, at that time he was at Amazon. He wrote about life beyond distributed transactions. And that's a very good paper, why it just simply doesn't scale. And that's why we don't use it in highly distributed systems. But the question is, the core problem doesn't go away. I might have like 3 things I want to do, and if the third thing crashes for whatever reason, I might have to roll back the other 2. But I cannot do it by simple transaction management anymore. So the answer to that, you might have heard of the Saga pattern. The Saga pattern is recently pretty well known, or you might know it as business transaction or compensation. So this is how it looks like in BPMN. So you can do something like, I have my payment, and now I extended it to also, first I deduct some customer credit. If he has some, I deduct it. And then I check if I have to get additional money. Then I charge the credit card. And it still can happen that charging the credit card will not go through. I have an error there, and that means the guy probably, because I fail his payment, that probably means he doesn't get his order, and that normally means he want to get back the credit, right? And this is how BPMN does do it. So you can throw a compensation there, it's called. This one throws it, and that means all the activities executed successfully in the past, which having such an compensation activity configured, for them the compensation activity is executed. And that's done automatically by an engine which is capable of executing BPMN. And again, it's stateful. So if you fail the payment and the customer credit service is currently not available, it's not a big deal. I mean, you have to retry it again. You have to make sure it's reliable. That's the important part. And that's kind of a Saga coordinator you can use for that. It's not the only pattern you can use, but I think it's one of the easiest to understand, at least. If you want to discuss these kind of things, by the way, feel free to approach me later on at the booth. And that's also, there's a lot of discussions going on about eventual consistency. So that's already eventual consistency because it means the charting of the credit card might not be possible, so I retry it, I wait here, and that's an inconsistent state because I deducted credit, but I have no idea if the payment will go through. But the important thing is I have to have that point where I make sure it's consistent again. And that means why it's eventually consistent. And that might pose a couple of problems you have to solve, but the important message here is, and also this is a mind shift currently, you should accept that. You should, that's on a business level, you should think about the consequences. That's much better than ignoring it and just assuming everything is working fine all the time. Let's probably also look at that. So what I did there, I have that same thing here. So that's what you had on the slide. And by the way, in the first example, I wrote 3 lines of code in order to define the flow. This time I used a modeler, a graphical modeler to define the BPMN. So you can basically use both. It doesn't matter. I always start with the code because I made the experience that developers, as soon as they see these graphical models, they're somehow afraid there's some magic in behind. And having the 3 lines of code, you at least know what's in the back. And the same thing I can do here, and as soon as it's more complicated, it makes more sense to make it graphically. So that's what I already talked about. And then I can do something, I can call that again, so that was V6. I do it, and I get a 202 accepted. Why do I get a 202? Let's quickly look. So this time I go to the V6, checking. Okay, it currently waits for the customer credit service. Well, the customer credit service is not there. Why is that? That's what I meant earlier. In this case, I used the what we call external tasks. So I basically have a topic where workers can ask for work, and I don't have any worker running. And in the example, if you want to play with it at home, I have this one. So that's just for the fun of it, I have written it in JavaScript. But it basically just pulls the REST API and fetches for work. So as soon as I start that, hopefully readable, it processed that payment. So if I go back and hit the retry button, it moved on. And now my payment service is still slow. So I put that back to normal. And as soon as everything is working, that's what I meant earlier, I'm basically switching back to a 200 OK. What you can also see, it's not slow. It doesn't mean to be slow just because you're having these kind of workers, asynchronicity, and that's a rumor that has to be slow. And just for the fun of it, I will make a couple of these things. Because sometimes the credit card payment will fail. I have a randomizer in there. I forgot the exact percentage, but that should do the trick. And then an interesting thing to look at is that we have a lot of statistics, and that's what I meant. You have a lot of context if you're using this kind of workflow engine, which you normally build in these message hospitals if you're using messaging. And then you can see how many of the instances went with which path, and you could look in the data. You can even do a lot of visualizations, or you can do a lot of analysis on that. So that's the beauty of that. That's what I mean by you're having context. You're not just seeing a dead message. You're seeing it in full context. Okay, so this is that. So that's, from my perspective, an important thing. So if you have clients, they should think about, okay, circuit breakers, obviously, but that was already pretty good in the audience. But also about, if you have asynchronicity, about timeouts, about retrying, stateful retrying. So if you use service mesh, for example, what they could do, they do an immediate retrying for network hiccups, but what I'm talking about here is stateful retrying. And you have to take care about compensation because of these kind of business transactions. In order to get that going, you have to make sure your service providers offer these compensation activities. That's one of the biggest problems with legacy systems. You can create an invoice there, but you cannot easily cancel or delete it. Very often these services are not there. And they have to make sure they're somehow idempotent. And if you're actually do that on the right side, if you're preparing all your services to comply to that, you're laying a good foundation actually to be successful in that distributed system world. So that's a very important thing. Okay, and that helps you a lot in solving these kind of challenges. So now I talked a lot about synchronous communication. I talked a bit about asynchronicity. Now I want to quickly dive into the basically event-driven world. So I have more or less the same example, the code example, also on a broader scale. There I do a very easy order fulfillment process. I show that in a second. And there I run a couple of microservices. In this case with Spring Boot again. And what you can see is in payment, that's basically what you already know. I have a workflow engine in order to do the stateful retrying. And I also have another workflow engine in the order component. And then I'm communicating event-based. I'm showing you what that means in a minute. And I have Apache Kafka underneath. Basically, because Apache Kafka is currently pretty hip. It could be AMQP as well. It could be, if you want to, it could be MQ series. It doesn't matter. It should be like a messaging underneath. And then I am having a monitoring component which just listens to everything on the bus and shows it on a simple web page so we can see something. So this is how it looks like. So I have the monitor. Creating to a WebSocket. Now I have a Spring Boot component on the server side, listening to Kafka, showing me everything what's going on. And I have a very awesome UI for handing in an order. Yes, thank you. I appreciate that. I made it myself. And it emulates basically an Amazon Dash button. You probably know that. So you can put the Dash button right next to, for example, the diapers. If you see the diapers are getting empty, you push the button, Amazon sends a package of diapers on the next day. You don't have to go to the web to order something. So that's a Dash button. It's reality. You can get that. And so that means I just push the button, and then in the background, an order is sent. And in an event-driven world, that basically means I send an event like something happened, order placed. And that's from the checkout component. Normally, I attach some data. That's not that important, for example, about the items which are in the order. And the next thing that happens on the bus is that I see a command that somebody wants somebody to retrieve the payment. So what happened there? And that's now the order component, the order service. And there, what I said earlier, there's, again, some workflow engine running. And quickly go in there. There's the this kind of order process. And that's actually, we don't dive because of the time into the code now, but it's also on GitHub. It's very easy to read. What I do there, in this case, I used Spring Cloud Streams in order to listen to Kafka. And then every message or every event I get, or every command I get, I basically check if I can correlate that to a workflow instance. And in this case, if I go to order placed event, it's basically triggering a new workflow instance. And that one is sending a command to retrieve the payment. And the next step, it waits for a payment received event. And the payment received event is currently not there because the payment service is not running. I could do that, actually. I could quickly start it. Where is it here? And there we have the payment service. If I start that, could probably take a bit because I'm quite stressing my computer here. So as soon as that is up, this workflow moves on. And if that takes too long, we could do something else. And that's actually also pretty neat to combine this event-driven world with these kind of patterns I basically presented earlier. So not sure if that's already up. it should be. So if I go back, I see that this one now moved on, and I also see it in the monitor. So that's, if you want to play around with that, the best is just check it out on GitHub. So probably if you just go to GitHub, whoa, and then there's the flowing retail. I have it on the slides, don't worry. And there's the example. There's a lot of like, README, how to get it going. And there's also all the rest stuff I was playing around with. So that's all on GitHub. One last important thought, because I discussed that very often recently. If you're looking at especially microservice architectures, a lot of people are kind of averse for topics like workflow engines or BPM or however you want to call it. And that's because they think that this introduced some central component, some weird workflow engine over there, and that often introduces dependencies in the deployment and conflicts in ownership, who owns the process, who owns the workflow engine, who redeploys it, and these kind of things. So that's kind of a messy situation. But again, it doesn't have to be that way. I mentioned that earlier. So I see these kind of workflows as being part of the service. So I probably have workflows in payment, and I probably have workflows in order, probably also in inventory, and then they are part of the service. I don't see that from the outside. It doesn't matter. The service provides an API, and within, as implementation detail, they might leverage workflow. And if they have these kind of stateful retrying capabilities, very often we make the observation that the API of the service even get easier because you don't throw all the failures to your clients, so you can handle them yourself. So that's kind of a pretty cool place to be. And then what we also see is that you have these kind of different use cases for this kind of workflow technology. For example, it can be very, very small. So what you saw in the very beginning, the Stripe retry, that was a one-node workflow. So that makes sense sometimes. Or you have these, what's up there, more like the end-to-end workflow, like from a business perspective. But without the details of the payment, they don't matter because they are part of the payment service. Okay, so as a quick summary, so I think it's very important to really think about distributed systems nowadays. Even if you call just one REST service, you have to think about it. What happens if that's not available? I cannot distinguish between it was not available or it got the request and I didn't get the answer. So you have to take care about these situations. And you should have the right things in your toolbox. So all these fail-fast service mesh, Hystrix, fail-safe, whatever it is, should be part of that. But it's not enough. You should also think about the stateful stuff like stateful retrying, waiting, timeouts, and compensation, especially Saga. And there are workflow engines out there which can do that very well. So we're pretty much on time. I actually have all the material up there, so you find it on GitHub. I upload the slides later on, so you'll find it on my SlideShare account. I also wrote on InfoQ recently about that. Currently writing 2 other articles. If you want to review an article, let me know. By the way, I almost forgot. I wrote a book about BPM and about the standard, so that's not at all about the tool. It's about what I can do with these kind of workflows. We have a couple of copies at the booth, so if you're interested, just pass by. I hope that was somehow interesting. I hope that got you further at least a bit entertaining in the morning. If you have any questions, I will be around. Send me an email, send me a tweet. Thank you for coming.